Okay, so for the final video for our moments, what we're going to do, okay, is we're going to look at this last kind of example, okay, and then we can move on to center of masses, which will still include these moments, okay, but for now, this is what's going to be for rigid bodies, okay. So for this example, we've got a few different things that are going on. Okay, we've got things at angles, and we've also got a hinge to think about, which we'll talk about as well. So let's jump into it. Let's draw a diagram and kind of go from there. So we've got a uniform rod AB of length 6 and weight 300 newtons is freely hinged to a vertical wall. So that means it's attached to a hinge which can move up and down. Okay, it's held in horizontal position by a light inextensible string BD, where D is a point of 2.5 meters vertically above A. Okay, a particle of weight 150 newtons is attached to the rod at C, where BC is worth 2. Okay, so we've got lots and lots going on here that we need to think about. Okay, so first of all, I've got a wall. So let's draw a nice straight wall to start with. Okay, and I've got my hinge by here, and I've got, in fact, let me draw a little bit away from the wall so I can label things a little bit. I've got a hinge here, and I've got my rod going that way. Okay, and then my rod is attached to the wall. Let me extend my wall a little bit by there. Okay, so that's the kind of diagram I've got going on here. Okay, now here's A, here's B, and here's D. Okay, so let's start with forces and then we'll do distances afterwards. Okay, so first of all, the rod down here, AB, has a weight of 300 newtons. Okay, I've also got this weight 150, which is at point C where BC is with 2, so it must be on this side over here. So I've got another 150 by here. Okay, it's a light inextensible string, so there has to be tension in it. Okay, and the last thing is I've got this hinge. Now a hinge is going to have some sort of resultant force at an angle, okay, but we don't know what those are, so we're going to split it into two components. It's going to have something in the x direction, and it's going to have something in the y direction. Okay, and then we can figure out what its resultant is and what its angle and stuff like that is afterwards. Okay, now I'd actually let's put some. In fact, let's put some distances on first before we go any further. Okay, first of all, the 300 newtons must be in the middle, so this must be 3 meters because the whole length is worth 6. So I'll label the whole length down below it. Okay, I've then got this length here is worth 2 meters, which means this length here must be 1 meter. Okay. And then the final thing they told me is that the distance between A and D is 2.5. Okay, now at the moment, if you notice, most things are working up and down or left and right, apart from T. T's at an angle. So I need to think about what this angle is here. Okay, and if we look, I've got a normal, let's think about what I've got. I've got a right angle triangle here. Okay, I know this is 6 down the bottom. I know this is 2.5. Okay, so I know that tan alpha, or sorry, tan theta, I call it the theta, is 2.5 over 6, which would be 5 over 12. Okay, so if they don't tell you an angle, okay, use some sort of geometry and trig, okay, to try and find out what that angle is, okay, which means I can do what sine alpha is and cos alpha is, because this is, sorry, cos theta and sine theta, okay, because this is one of my special ones, okay, 5, 12, 13. So sine's going to be 5 over 13, and cos is going to be 12 over 13. Okay, again, that makes things a little bit easier for me to do. Okay, so that's everything I need to know. Okay, now for the first, I've got two things I want to do. First thing I want to do is calculate the tension in the string. Okay, and the second thing is find the magnitude and direction of the forces exerted on the hinge. Okay, so first thing I need to do is tension. Okay, now let's think. I've got 3 things I can do here. Okay, I can resolve forces vertically. I can resolve forces horizontally. Okay, because everything's in equilibrium. And then I can take moments. So those are 3 things I can do. Okay, now if I want tension, I don't want X and Y for part A. Okay, I want to try and get rid of these. Okay, now if I resolve vertically or if I resolve horizontally, it's going to include an X and a Y, which I don't want to do. So I need to try and get rid of them here. So I need to think about how I can. Okay, and the way I can is I can take moments. Okay, so I'm going to do moments, okay, about the hinge. and put a bracket, that's A. Hinges at A, isn't it? Okay. That's going to eliminate X and Y, so I can then do every other force. So again, it's an equilibrium. Clockwise should equal anti-clockwise. So the 300 and the 150 are both clockwise. So I've got 300 times 3, because it's 3 away. And I've got 150 times 4. And the other side, I need this component. So I'm going to have T sine theta times by 6, because it's 6 meters away. Remember, I want its vertical component for T. Okay, so I need to make sure it's perpendicular. Then let's just jump into it. This side is going to give me 1,500. The other side, I'm going to have 30 over 13t, because I can plug in my sine from over here. And then that gives me T as 650 newtons. Okay, so there's my tension, nice and easy. Okay, so think about if you don't want, do things, if you don't want certain forces, get rid of them by taking moments about them. Okay, because in part B, I want to find the magnitude direction of the force exerted to the hinge. So I need what's the resultant on the hinge. Okay, so I need X and Y is the point here now. Okay, so to do that, okay, I'm going to follow the other things. So I've already taken moments. Okay, now I could technically take moments again. Okay, but instead I'm going to resolve forces instead. Okay, so just because it's a little bit easier, I don't have to worry about all the distances involved. Okay, it makes things easier for me. So let's resolve vertically first. Okay, if I resolve vertically, things going up should equal everything going down. So things going up is Y. Also going up is the component of tension, so T sine theta. And everything going down is the 300 plus the 150. Okay, so this gives me 450 on this side. Okay, I know what tension is, it's 650. So I end up with 650 times sine, which is 5 over 13. Okay, now if I solve that for Y, Y comes out as 200 newtons. Okay, there's my Y component. Now let's resolve horizontally. Okay, same kind of thinking. So going horizontally, left should equal to the right. So everything going to the right is X. Everything going to the left would be the T cos of 60. Okay, these two are going up and down, so they don't affect them. Okay, this is the only thing that's moving left and right. Okay, so that gives me, again, let's use the T that I've got. So X must be 600 newtons. Okay, so they're the two components. Okay, but I need the magnitude and direction. So overall, let's think about what's going. I've got 600 newtons this way. I've got 200 newtons going up. I want its resultant and its angle. Okay, so first of all, let's start with this resultant. Okay, simple, normal Pythagorean stuff. So 200 squared plus 600 squared gives me 632.5. Okay, and then its angle. In fact, let's not use theta because I've already used it. Let's use alpha instead. Just run alpha. Okay, is going to be tan. So minus 1, 200 over 600. Okay, which is going to come out as 18.4. Okay, so don't assume that just because you've got a hinge, it's always going to be perfectly in the middle. That's not always the case. Okay. Take moments about certain points to eliminate them, resolve vertically and horizontally to find other things at the same time. Now, technically, I could have formed some equations and then solved them simultaneously if needed be, okay, but I didn't need to in this scenario, okay? So slightly harder, okay? However, as I'll show you now, that something like this has come up before. Okay, so there are the two papers. Okay, the first one, okay, a little bit of proof, little bits of algebra for this to deal with. Okay, so just take your time with that kind of question. And this one here you go. Here's my hinge. I've got it attached. Okay, find the length, find the magnitude direction of it at the hinge. Okay, worth 8 marks. Okay, so there's probably something else you need to do. Okay, probably the tension in the string up here. Okay, and you may want to eliminate it or find it in some scenario. Okay, so apart from that, okay, have a go at those. There are some more, again, some old spec questions, okay, so you can look those up as well, okay. But apart from that, that's the moment. If there's anything else, let me know. Bye. But apart from that, I'll see you in the next topic.